So, good evening, everybody. My name is Emmanouil Potetsianakis. I'm going to present you the work about we are doing in a multimedia lab of Telecom ParisTech in browser XML document streaming. It's a work we are currently active, me and my colleague Cyril Concolato. First, I'm going to start by showing you the outline of my presentation. I'm going to show you what's happening now in multimedia in conjunction with XML, since I understand that most of you are only on the XML part and less on the multimedia, at least at producing content. Then I'm going to show you the state of the art on what we are going to do, which I'm pretty sure you're going to be familiar with. And I'm going to present you the technique we developed for XML document streaming, then followed by the platform we are using in order to achieve it. And then the two scenarios we are considering, which is multiple document streaming and fragmented document streaming. Finally, I'm going to do a very simple, very short demo in order to show what I'm talking about. So the facts about XML and multimedia are, from our perspective, are simple. There is a huge growth in audiovisual content distribution. According to Cisco Visual Network, from 66% of the total traffic, IP traffic in 2013, it's going to expect it to rise to 79% of the total internet traffic in 2018. And on the other hand, we've got XML, which is often used as subtitles, metadata, or whatever, and goes along very well with multimedia for such purposes. Some common examples are the TTML and SVG graphics. However, there is not enough progress in the sense of carrying XML alongside the multimedia content as the multimedia content's popularity rises. This is a simple example showing how we can have audiovisual content in conjunction with SVG. As you can see, we have a video inside the browser, and on top of it, an SVG layer showing some information and color graphics overlaid on top of it. In such scenarios, as well as the subtitles and all that we mentioned before, it's very important to have synchronization with the audiovisual content and as well ease of distribution of the multimedia content and the XML documents. This is why we chose MP4 container in order to pack those stuff together. And besides our solution, other people proposed some interesting stuff, but not good enough for us. There is the standard W3C called Rex, which is remote for events for XML. It was originally focused on DOM events, even though I suppose we could be used to XML, but it was dropped. Hence, there is no really a reason for discussing it anymore. There are several MPEG considerations for transferring XML, like textual encoding with TEM or binary with BEAM, or the BIF representation with XMT, which are suitable for MP4 containers. However, they are not deployed in browsers yet, even though we are able to show multimedia content in MP4 very easily. There is not a consideration for the XML accompanying it. We've got Apple with HLS, which is in ID3 format, and we can host XML in the text element that they have considered, but it's only for iOS. And then I guess the question you pop up in your mind as soon as you saw the title is, why not use AJAX? The reason is very simple, that we cannot actually package the multimedia alongside the XML. Usually it's in one place, the multimedia, and another one, the XML, and then we fetch it and doing the synchronization. And also, it's exclusively for online scenarios, while with MP4, we can use it for offline as well. This is why we propose the XML streaming, which is packaging the XML documents in containers. Our first scenario is one XML document per time range. By time range, I mean a starting point for the XML document for a certain duration. It's simple. It covers the most common scenarios, like, for example, TTML subtitling. However, it can introduce latency if we are having large XML files, because we will have to wait for them to download in order to proceed, or overhead if we have redundant files. This is a rough outline of an MP4 container. You can see that in this case we've got two tracks. The upper blob represents the multimedia content, and in track 2. And in track 1, we've got 3 XML documents. First XML, second .xml, third .xml, blah, 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 assigned to 3 time slots that are bound to be transferred. The second scenario is 1 XML section of a document per time range. It's suitable for progressive document loading because we can fetch fragment by fragment the XML. Hence, we can use it for documents with integrated timing more easily than we could without timing, and allow seeking within a content using a random access point. In order to achieve this, we usually set a header, which is some required information in order to decode the fragments. The header is transmitted whenever we want to transmit an XML section as well. And in this packaging scenario, you can see here the green blob in track 1 is 1 XML file, separated in fragments by the dots you see. And the first part, it doesn't have a time slot assigned since it's the header. And the rest of it is how we choose to fragment it. And over here, we don't define if it's a random access point. It's just for showcase. So in order to achieve what I'm proposing, we are using Gpack, which is a project on advanced content, an open source cross-platform multimedia framework developed in ParisTech. It's more than 10 years of work. And we're going to use 2 parts of Gpack for what we are going to do. MP4Box, which is a packaging solution for ISO file formats, and supports XML using NHML descriptors. This is for every kind of XML because, for example, for TTML, we don't actually use NHML descriptors, but we can generalize it like this. And it can produce Dash-ready content with a small question mark next to it because we are not 100% yet ready for XML in Dash. And then we've got the MP4Box.js browser library, which exposes the information inside MP4 files. And hence, it can extract samples from MP4 that contain XML, usually suited for text tracks. This is a more detailed schema of how we can use multiple document streaming. You can see that we've got different multiple documents assigned with time slots. They are accompanied by 1 XML document packaged into an MP4, transmitted, and then when they arrive at the browser, we extract the information and separate the XML with the audiovisual using MP4Box.js. On the lower part, you can see sampled NHML descriptor file, which we use in order to specify the timing. We define the namespace of the XML file, the media type, media subtype, track ID, timescale, and other synchronization. For example, the media type meta is for generic metadata, and the metx is for XML-specific metadata. This is why it's suitable for XML documents. The DTS, UC, and timescale are used in order to synchronize with the multimedia content. So we are using a multimedia definition of time in order to have better synchronization. We define for every document if it's wrap, which is always the case since we've got independent XML documents. And then we show the file we want to input. For the fragmented document streaming, we've got similar HTML files that specify how we split the document. And again, we define the media type, media subtype, which in this case is METT, meaning for text. We are using it in order to fragment the XML document. Since we do not have a valid XML file, we cannot use metx. And we define the fragments by setting the XML elements we want to include. We can also do it by byte range, but since we are XML people, we don't really care about it. And this is in the same file I showed you before, fragmented with its respective NHML file. So you can see how it's used. And over here, we chose to be wraps, but it could as well not be. And the header includes the first element for some purpose. I don't know, I'm not an author. And this is a snippet I was asked almost everybody that I got feedback from of how we can use MP4Box.js. First, we create an instance of the MP4Box.js. We set the extraction options. And then for every sample that we arrives, we are able to see its type, if it's METT, METX, subTT, or whatever. Then we can parse the sample and add to queue. The sample that I'm talking about is displayed in JSON format next to it. You can see the timing information that we have for every sample, which is timescale, DTS, ETS that allow us to have the actual timing, the duration of the sample, and then where it says data, it's the XML document on fragment. But in order to make it clear, I will show you the simplest use case we can have. So over here, I've got some files, and we've got a METT suitable file, which is for fragmented document streaming. So we've got this input, one document with 3 elements. We define it with this HTML file. So we specify that the first one is wrap, the second one is not, the third one is not. And we can see that we can also add doc.end as definition, even though there is not such ID. I've got a simple HTTP server running. I'm going to use this one. So the files are here. We are going to create a new MP4 file. There we go. Put it inside the server. This is a sample interface of MP4Box.js. You can find it on the GitHub. I will give you the link later. And it's running locally for now. We specify the URL. Since we are talking about fragments, it's in the text field, so I will filter the console to get only text-relevant messages. We don't have to initialize buffers since we don't have any video inside. We can see what information we've got before we actually parse the file, just by analyzing the MP4. Then we use to load the media data. And we can see that the document is split and transmitted according to the HTML file. You can see the timing information we've got available here, here, and here, specified by DTS and the timescale, and the elements, how they are split. Moving on to the next example, we've got 3 XML documents, this one, this one, this one, and the respective HTML file. Again, everything is wrap. We define the file names. The duration for the last one, since we don't know how long it's going to last, because from the previous one, if we don't specify a duration, it lasts until the next fragment arrives. And we define the namespace, the schema if we want, and the subtype to metx because we've got different documents. Moving on to MP4Box.js. This time we've got full XML documents, so we change the filter. Again, the information we've got. And then we can load the data. Oh, forgot to reset. Okay, going back again. We select the track we want containing the XML documents, and then we can load the data and show the XML. We've got again the timing information, which is the same as before, and the full XML documents parsed inside the browser. Now, going back here, if we want to, for example, to directly adding to queues instead of just displaying it on the console, we can use the VDTQ function by saying that we want to have a start point defined by the DTS and the time scale, again, and an end point extracted by the duration of the sample that we've got, and finally define if it's XML or a fragmented document. It's important to notice that in the fragmented case, we should have specific consideration inside the browser because usually there is no consideration for it. But for example, SVG are working on a draft for SVG streaming, which can consider open SVG documents, hence unbalanced, and load it progressively. And with this implementation, we are able to foresee it. And the last point is that even though we've got only one file, it's a completely valid MP4 file. So if you've got a simple MP4 player or an MP4 browser not having the XML extraction capabilities that MP4Box.js provides, it will play the audiovisual content as normal. In case you want more information, you can go to the Gpack webpage. You can also find documentation on an HTML file and a lot of examples on how to package content. For the MP4Box.js, you can find the code for the same demo I showed you online, as well as some already made MP4 files. And also specifically for NHML and TTML, you can look at Cyril's webpage. And if you want to contact me, you have to find my first name and last name, because I guess you don't remember it, or Cyril's, and send me an email. Thank you very much for your attention.
So we even have few time for questions. Yeah?
That was pretty cool. Congrats. I was just wondering, I don't know if you've heard that the W3C Technical Architecture Group and Web Applications Working Group are working on a draft for a streamable packaging format for the web. Are you aware of that? Are you considering using that as well?
No, I have not heard of it.
Okay, I'll send you the pointer then.
Oh. Nice. Other comments or questions? And thank you very much. Thank you very much.
Thank you.